It's been around for over 50 years, but it's always been seen as economically unviable as long as the costs of getting things into orbit and building large structures in orbit were very high, which they have been for decades until the last 10 years or so, where things have dramatically changed. So through this initiative, we really wanted to get that hard data to convince ourselves and our stakeholders that, yes, now everything has come into place, and the challenge for, of course, decarbonization has only grown in that time. Everything has come together to really show us that we do need to move forward at pace to develop this capability here in Europe. So as part of that initiative, we funded some technology development activities, and we did concept studies for how you might build full-scale, commercial-scale space-based solar power. So wireless power transmission, or power beaming, it's sometimes known as, is probably the most science fiction part of the whole concept of gathering energy in space and delivering it down to the ground. Because, people can understand putting a large solar farm up in space, but how are you going to get that energy down? Not with a long cable. So actually delivering energy wirelessly is something that we don't see in our everyday lives down here on Earth. Most people aren't aware that it's actually a thing, but it actually goes all the way back to Nikola Tesla more than 100 years ago, who had grand visions of being able to transfer energy wirelessly across the planet from towers distributed across the Earth that could beam power to different parts of the planet. He wasn't successful with that, although he was successful with transferring energy across the distance of a room. But it wasn't until technology improved back in the 60s in the US when people first started to demonstrate that you could, in a directional way, in a focused way, send wireless power across the distance. And since the 1960s, there's been dozens of experiments from international organizations across the world who've shown repeatedly that energy can be moved from one point to another, from the ground into the air, across distances from meters up to kilometers distances, and at power levels of up to a few kilowatts. So we know the theory, we know for a fact this can be done, certainly at small scale, and it's been demonstrated many, many times on the surface of the Earth, at least, and up into the air. But what we haven't done is shown that it can be done at a much larger scale to deliver huge amounts of power over much longer distances, like what would be needed from space to Earth, which we're talking about thousands of kilometers. So it's really not a question of science or understanding some new physics, but really being able to develop, from an engineering perspective, large enough antennas to beam that power, to transmit that power, and large enough receivers that can receive that power to be able to make this a useful technology if you want to use it for power delivery at scale. It's about the demonstration that we did in Germany in 2022. So that was done at a hangar at the Airbus, a space company in Europe's facility, where we beamed across 36 meters, 2 kilowatts of power, as you said. And I was stood a few meters away from where this invisible beam of power was going across from a transmitter that was about 2 by 2 meters squared to a receiver the same size on the other end. And we fed that power into the electricity that came out of the receiver into a small mock-up of a city to show it could light the lights of a city. It also went into a small hydrogen electrolyzer to split water into hydrogen and oxygen. And some of that power went to cool some beers in a fridge as well. And so we got to
the most important test case. That is real utility right there.
I'm pretty sure we had the world's first wirelessly cooled beers that anyone has ever had, because this is Germany. So we know it works, and we did it in a safe way because we were measuring the power levels that were kind of leaking out of where this beam was being sent, and it was extremely low and within all the safety limits. So the technology is there, it's known, it's proven. But first of all, space-based solar power has a myriad different applications, from the smaller scale where you might send power to users that need relatively small amounts of power, but need it in a place that they can't get it otherwise. So, for example, for defense applications, forward operating bases where troops are away from the grid and access to energy, they typically fly in diesel for running generators. And that has huge logistical costs, also costs in human lives as things get ambushed. So being able to receive even, say, a megawatt or so of power when you need it, where you are in these remote places, can be very valuable for such an application. But on the other end of the scale, if you want to really power cities and countries and help make a dent on our energy transition and climate goals, you need to provide power at the levels of hundreds of megawatts to gigawatts, like a nuclear power station, a fossil fuel power station, and many of these eventually. So that's another scale of the problem versus the small end. But if we look at the top end of the scale, where we imagine space-based solar power contributing to a good fraction of the world's energy needs into the future, you'd need to be able to build gigawatt scale power plants, which would mean that you need to put up something similar in size to the solar farms, the large solar farms we have down here on Earth. So think of an area of some square kilometers in size. That's pretty big, of course. And looking at what we've built in space so far historically, there's been nothing even 100 times smaller than that built by humanity so far. So this is the first problem when people compare it with what we've been doing so far in space, that naturally scares people. In fact, it took me 6 months to get my head around the idea of what we were trying to propose to do here. But the thing to remember is that, things have changed a lot in the last decades. The International Space Station, for example, which is the largest object in space that's ever been built, was put together by astronauts, built out of very complicated large parts, launched with the space shuttle in. And that's a very different kind of structure, infrastructure, and build process than is imagined to be done for something like space-based solar power plants, where by design, especially the more modern designs people are working out, are very much modular. So think of just a solar farm on the Earth. It may be huge, maybe kilometers across, but it's all made up of 2 meters by 1 meter size solar panels, which are put into place by people onto racks and just repeatedly done 1 million times. And this is how the designs of new space-based solar power stations typically are also considered now, to be very, very modular, made of mass-produced parts in factories down on Earth, using automotive consumer electronics types of production technologies. And then all of these are flat packed into rockets, launched into space, and put together by robots, not human beings, not fleets of astronauts, but autonomous robots. So it's these kinds of capabilities which are coming online now. Of course, we haven't demonstrated it at this scale ever before, but we're seeing the building block technologies are there. And we believe that with development and experience, we will be able to put these things together, built up over time into these large structures. So that's the first problem, the scale, which of course hasn't been demonstrated, but there's every reason to believe that we will be able to work out how to do this. And don't forget, in the energy sector on Earth does really big things. If you think about a nuclear power station or a hydroelectric dam, those are huge, structures, and the Burj Khalifa in Dubai at almost 1 kilometer tall. People know how to do big things if they put their mind to it. It's just that we haven't done it yet in space, and we have to prove it.